Hello everyone, welcome back to another video on chemistry. Today we'll be looking at organic chemistry and in specific the reactions that occur in it. The type of reaction we'll be looking at today is an elimination reaction, in specific an alcohol elimination reaction. In general, the formula for an alcohol elimination reaction is where the reactant is an alcohol, the catalyst is sulfuric acid at 100 degrees Celsius with two products. One is an alkene and the second is water. The reactant that we will be looking at is going to be an alcohol, obviously, which is Pentan-1-ol. And the products that are going to be produced is going to be Pent-1-ene and water. So going ahead and drawing in our structural diagram for the reaction, we have Pentan-1-ol, so pentan, that's 5. So drawing our 5 carbons. And it has a alcohol group on carbon number 1. So I'm going to go ahead and draw that, and I'm going to fill in the insignificant hydrogens for the rest of the carbons. So we know that in an elimination reaction, a reaction that occurs when 2 atoms or groups are removed to form a pi bond. But when we are making bonds, which is our pi bond, we have to follow Zaitsev's rule. And Zaitsev's rule is going to tell us where to take our hydrogen bond from. So in general, the hydrogen atom is most likely to be removed from the carbon atom with the most carbon-to-carbon bonds. So the poor get poorer in terms of insignificant hydrogens. So let's zoom in on our molecule and do the reaction. So we're going to obviously break our hydroxyl group or the alcohol group off, and we see that this carbon over here is attached only to this carbon. There's nothing else on the left. So we're going to take carbon number on the top, make it significant, and break its bond. You could take the one on the bottom, it does not matter. And we're going to create our pi bond. So now if we go ahead and draw in our products, we have 5 carbons. And I'm going to go ahead and draw my insignificant hydrogens. But before that, let's draw in our double bond or pi bond that we created. This carbon, terminal carbon, is going to have 2. It's going to be in a trigonal planar format because it's a double bond on a terminal carbon. Second carbon gets 1 insignificant hydrogen, doesn't matter if it's on the top or the bottom, and filling in the rest of the insignificant hydrogens. And now I'm going to follow through with the reaction and finish the reaction of the hydrogen and the alcohol. So now, if we were to name this reaction, we have Pentan-1-ol reacting to produce Pent-1-ene and water. Pause, look at this. We see that we have an alkene. Isn't it supposed to be cis or trans? No, not in this case, because when there's a double bond to a terminal carbon, the insignificant hydrogens follow through on a trigonal planar format, and so there is no cis or trans formation. It's just Pent-1-ene. So that is the reaction that occurs for an alcohol elimination reaction for Pentan-1-ol. Now, answering our application questions, it asks, what rule did you use to predict the products? We used Zaitsev's rule, where the poor get poorer, right over here. Okay, and if the molecule is Pentan-3-ol, predict your products. So I did the reaction already with the 2 possible products, so let's just zoom in and look over this again. So we had Pentan-3-ol, that means the alcohol group has to be on carbon number 3, right over here. Okay, and Zaitsev's rule says the poor get poorer. So if we look, there's 2 carbons on either, there's a carbon on either side, 2 of them, and they're both equally poor with 2 insignificant hydrogens each. So it doesn't matter which side I take it on, no, because it's going to be the same. To show you guys, I did one where I take it from the right and one where I take it from the left. They're both the same, they're just reflected. The naming convention would be the same as well for when we're naming the alkene. So I took the hydrogen from this carbon right here. I broke its bond off. I broke off my alcohol bond and created a pi bond in between. And it's the same thing that happened over here. And we see that when the reaction occurs, we end up with 2 possibilities. One is if it's a cis and the other one is a trans. So how do we know if it's a cis or trans? When we have an alkene, depending on how the insignificant hydrogens are formatted or placed on the carbons between the double bond, you will know if it's a cis or trans. So for this one, they're both in the same direction, so then we have a cis. If they're on opposite directions, like over here, you end up with a trans formation. So in a molecule, if the molecule was Pentan-3-ol, the products that would be produced is cis, Pent-2-ene, and water, or trans, pent-2-ene, and water. It could be either or, and again, it depends on the format of where your insignificant hydrogens are placed for the 2 carbons that are involved in the double bond. Now, answering the question, explain how this question is different from the first. Well, if we go back to the first question, we can see that the reactants are different. The first reactant is Pentan-1-ol, the second reactant is Pentan-3-ol. Secondly, the products that are produced in both vary. The first reaction, the product is always going to be one set of products, which is Pent-1-ene and water. There's no other way, there's no cis, no trans, because again, it's a terminal carbon with a double bond. Whereas for the second reaction, it is not a terminal carbon, and there are 2 possible products that can be produced. One would be a cis or a trans, depending on where the insignificant hydrogens are placed. So, in summary, the first question, there's only one set of possible products, if you will, whereas the second question, there are 2 possible sets of products with cis and trans. Thank you, and that concludes my video, and I hope you learned all about elimination reactions.